this lesson continues with a couple of proofs that might lean a little bit more towards the challenge side, but if you just take them step by step, they're really not too bad. So in this proof, we know that ABCD is a rectangle. So that means we get all of the properties of a parallelogram and all of the properties of a rectangle. We want to prove that CEB right here is an isosceles triangle. That means we need to prove most likely that EC equals EB. Well, in thinking about that those two would have to be equal, those are parts of the diagonals. I'm going to go to my properties that talk about the diagonals and see if I can get those two pieces. So that's my plan. So, first step is always the given. Now, if I'm thinking about my properties, one of the things that I know is that those diagonals are going to be equal. So I'm going to go ahead and say that DB is equal to AC, and my diagonals are equal by properties of a parallelogram. And you don't need to write equal diagonals, but I am going to tell you which property I'm using just so that it makes more sense. So I know that the whole length is equal. Now I also know, since this is given to me as a rectangle, that the diagonals bisect each other. So that means that DE is equal to BE and AE is equal to CE. And that is by property of rectangle, because the diagonals bisect. So I know this, like that. Now, if the whole things are equal and I'm cutting them both in half, it pretty naturally follows that those pieces, all four of those pieces, are going to be equal. But I do have to prove it. So we're going to go back to one of our old initial properties, and that was that parts to whole bit. So I'm going to say that DB is equal to DE plus BE, and I'm going to say that AC is equal to AE plus CE by parts to whole. Now remember, I'm trying to get that EC and EB are the same. So what happened when we use parts to whole? Most of the time, we end up doing a substitution. So the first thing I'm going to do is substitute and set my sums equal to each other. So I have DE plus BE is equal to AE plus CE. That is by substitution. Because the whole lengths were equal, I could go ahead and set them equal to each other. Now I want BE and CE alone in my problem. Right here, I know I have some potential substitutions. So step 6, I want to rewrite this in terms of, I really have too many variables. So DE and BE are the same, so I'm going to replace this one and say BE plus BE is equal to AE and CE are the same, so I'm going to replace this one, CE plus CE, substitution again. Now at this point, I'm really going to do a little bit of algebra. If I have BE and BE, I really have 2BE plus 2CE, and that's really addition or combine like terms. Oops, is equal to. If I divide both sides by 2, I end up with BE equals CE. It's by division. I have what I want, and so if you think about the picture, now instead of these guys being different, In step 8, I proved that they are the same. If they are the same, then my proof is done. By definition, triangle CEB is isosceles. By definition, isosceles. And that's all there is to it. So nothing crazy, just a little bit of work to prove that what you felt in your gut was true was indeed true. Now the next one in this lesson is a little bit more complicated, at least initially. So we are trying to prove AX and CY. Now what I see when I see AX and CY is that they are parts of triangles. And I see this triangle right here, and I see this triangle right here. So what I'm thinking is if I can prove those two triangles congruent, then AX and CY would be equal by CPCTC. So that's kind of the plan I'm going to set out going for. What I'm given is a couple of parallelograms. So this is a parallelogram, and this is a parallelogram. Why does that matter? Because parallelograms give me equal sides, they give me equal angles, they give me parallel, all of those properties. So I will start with ABCD and DEBF are parallelograms, and that's given. Now when I look at my orange dotted triangles and think about wanting to prove them congruent, I have 4 ways: angle, side, angle, 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 side, angle, side, 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 side. Don't know if they are right, so I don't have the option of HL. I see initially that this angle and this angle are equal because of the parallel lines in the transversal. So I'm going to say that angle DAX is equal to angle BCY because parallel implies AIA. Now, if they're parallelograms, I also know that DA is equal to BC because opposite sides of a parallelogram are equal. So this is a property of a parallelogram. Now, in looking at my picture, I have a side and an angle. Since I'm after AX, side, angle, side isn't going to work. So I'm looking for angle, side, angle, or angle, angle, side. So now I have to see if I can figure out another angle in my picture. It's the only way I can prove parallel. Okay, we're good. Now where was I? So, to get those angles, so I'm setting out, I don't see any obvious way that I can get DAX equal to CYB. So I do know things about these angles up here. So I'm going to set out to try to get those angles equal. So one of the things I know, one of the things I'm given, is that ADCB is a parallelogram, which means that the big angles, angle ADC is equal to angle CBD by properties of parallelograms. Opposite angles are equal. So I know the big angles. If I start looking for the smaller angles, what I know then, if you look at parallelogram DFBE, the one in green, I know that this angle and this angle are going to be equal by the same reason. I know that angle FDE is equal to angle by property of parallelogram, opposite angles. So much the same as the last proof, what I have going on now is if I know the big one and part of the little one, by parts to whole, I can get these little pieces here congruent. Triangles are congruent. So let's go ahead with our parts to whole statements. And so I know that angle AD ADE is equal to angle ADF plus angle FDE. And I know that angle BCY is equal to angle CBY plus YBF. And those are all by parts to whole. So I know that the big angles are equal. I know that the big angles are equal. And so what I'm going to do is then set the sums equal to each other, that I have angle ADX plus angle XDE is equal to angle CBY plus angle YBF. That is by substitution. Now I'm going to go ahead and replace from the other equal parts, the angles I already know are equal. And when I do that substitution, I have angle ADX plus angle FBY is equal to angle CBY plus angle YBF. So I replaced right here. If I have FBY, YBF on both sides, then what I can do is I can subtract that value from both sides, and I have angle ADX is equal to angle CBY by subtraction. Once those two angles are equal, we go back to our picture. Now I have this angle, and this angle are now congruent. My triangles are congruent by angle, side angle, and my proof is complete by CP/CTC. So, step 10, triangle ADX is equal to triangle CBY by angle, side angle, and then AX is equal to CY by CP/CTC, because those are corresponding parts of those triangles we just proved congruent. So we worked for those orange triangles. Once they were congruent, the two yellow pieces by CP/CTC.